All right, so we're doing modeling and optimization. So we are on to number 10 now. So number 10, these ones are getting to be a little longer, so I'm probably gonna like just write important information down instead of like the entire problem, just because they're like paragraph problems now, and that just seems like a lot to write. So a 216 meter squared rectangular pea patch, so that's the area of it. So 216 meter squared rectangular patch is to be enclosed by a fence and divided into 2 equal parts. By another fence parallel to one of its sides. So that means that it could be parallel like lengthwise or widthwise, but it's going to split it in half. What dimensions for the outer rectangle will require the smallest total length of fence?
Oh, that's parallel. I drew that weird cursive view.
Oh, that?
Yeah.
Wrong class.
Yeah.
And then how much fence will be needed? Because we've also got to account for that middle piece coming across. Alright, so I'm going to draw my lovely patch here. I'm actually going to draw it twice and look at it. So we could divide the patch this way. That's not in the center. We could divide it this way, or we could divide it, this way, okay? But I want to use the smallest amount of fence, so which way should I probably divide it?
The left way.
Okay, the one on the left. So, in terms of dimensions, okay, we've got a width here, and then all of these others are going to be lengths. Okay, it doesn't really matter. I'm just, which one's width, which one's length. Going to get the same thing regardless, so. And we know that area is equal to 216 meters squared, which is equal to length times width. So if I want the perimeter of this fence, what would the perimeter be equal to? So 3L plus 2W. Now, with this up here, I can solve for one of the variables because I obviously want everything in terms of one variable. So which one do you want to do, length or width?
Wait.
Do you want me to solve for length or width up here? It really doesn't matter. It's
I
gonna,
said width.
okay. So width is equal to 216 divided by length. So I'm going to replace this width with that value. So 3L plus 2 times that would be 432 over L. over L. Another way I could write this, for the sake of the fact that I'm going to have to take the derivative, would be 3L plus 432 L to the negative 1. So I'm taking the derivative of perimeter with respect to length. So what would that be? Yep.
Yeah.
Subtract 1. So we set it equal to 0. So 3 is equal to 432 L to the negative 2. Since this is L to the negative 2, I can actually write this over L squared. I can swap the L squared and the 3. So 432 over 3. I don't think that goes in there nicely, so that's kind of unfortunate. Or maybe it does. Does it? I need to find out. 432 divided by 3. 1, 3, 1, 3, 4, 12. Oh, it does. Look how pretty that is. 4. 144. So L squared is equal to 144. So L equals 12. And we were given units, so the length is 12 meters. So then if I plug that back into the width equation, width is equal to 216 divided by 12. I'm pretty sure that goes in. What is that equal to? 18 meters. So my dimensions are 12 by 18, and that's in meters. So that's part of what it asked me for. And then it also wants to know the total fence length that I need. So I'm going to plug it back into the perimeter equation. So P is equal to 3 times 12 plus 2 times 18. So is that 36 and 36?
Yes.
So that would be 72 meters total of fence that I need. Feel smarter now?
Yeah. But hey, come on, let me know how much fence we need.
That's what, so we haven't done these problems yet, but we're getting to them. So, well, we kind of did these, I think last year we did like a couple in pre-cal, like the problems where it's like the shadow of the tree is this length or whatever. Yeah, so it's like, what is the height of the tree or something like that. So my dad, we had these trees that needed to be cut down. Well, the price per tree is based on how tall it is. Or like to an extent, it's how tall the tree is. So he was like, I want you to go out during peak sunlight and I want you to measure the shadow and tell me how tall the tree is. I was like, Dad, do we really care that much? He was like, no, I'm just curious. I never did it. But I was like, you want me to go out and measure a shadow of a tree to tell you how tall it is? It's like, that seems like a lot of work. He's like, well, you know how to do it, don't you? I was like, well, yes, I can figure it out, but I was like, doesn't mean I want to. It was a good time. Hello. All right, let's look at 14. Yeah, so this next one probably will too. It's that whole page for me.
Oh, yeah.
All right, so 14, it says the height of an object moving vertically is given by s is equal to negative 16t squared plus 96t plus 112.
Okay, follow-up question. Can I go to my car to record my homecoming speech?
You have to record them yourself. You're not recording them with Mr. Fletcher?
No.
Oh, that's new.
I mean, we can. We were given the option, but
Oh.
it's due today.
Yeah.
It's due today.
My excuse was I had 3 tests today and I showed up home at like 10 o'clock.
So, anyhow, that's fine with me. And then I'm going to take my 15.
Okay, have fun.
9 o'clock.
Don't forget to sign out.
Good thought. I should have done that when I was over there. That would have been smart.
I would just go back and just say that you're signing out because you're doing your homecoming. I told you to go ahead and sign out because as soon as you're done with that, you're leaving.
Okay.
Or something. I don't think they're going to care, but I don't care. But, you know, some people care, so
I got it.
I'm made to care. Okay. S is in feet and T is in seconds, so I'm just going to put that
Where's the S then?
position. And then find, so the first thing we're finding is the object's velocity.
You said S is in feet?
Yeah.
Okay.
Object's velocity when t is equal to 0. And then B wants us to find the max height and when it occurs. And then C is the velocity when S is equal to 0.
There are people laughing.
I can't do like things when like everybody's talking. I'm like, I can't do it. Certainly not calculus. Yeah, that too. Basically, the AP classes, I can't stand to do them with people talking. Makes it a little bit difficult. All right, so velocity when t is equal to 0. So how do I find velocity given position? Take the derivative. So velocity is equal to what?
Negative 42.
No, that's 16 times 2.
32. 32. Definitely did not say 42. Plus 96. On there we said 42.
All right, and then we want it when t is equal to 0. So v of 0 is equal to 96 feet per second. So now for max height, so the part A, we've been doing that since like chapter 3. No big deal. Part B, it wants the max height and when it occurs. So max height is where we're taking the velocity and we're setting that velocity function equal to 0. So we're saying that negative 32t plus 96 is equal to 0, and we want to know where that happens. So I can subtract 96 over, so negative 32t is equal to negative 96. Divide by negative 32, t is equal to 3. So we take the velocity equation and set it equal to 0, and that's going to tell us when it occurs. So this is, so it's happening after 3 seconds or at 3 seconds. So now we need to go back and find the height. Well, to do that, we need the position function. So we're going to take this time, okay, we're going to put it in here. This really could have been written as S of t, okay. So S of 3 is equal to negative 16 times 3 squared plus 96 times 3 plus 112. And I'm going to let y'all put that one in your calculator because that doesn't seem like something I want to do in my head. In its position, so it's feet. So the max height is 256 feet, and that occurs at 3 seconds.
I think it's moving at 85 feet per second. That's pretty fast.
That is pretty crazy.
Yeah, that's pretty fast.
85 feet per second. Wow. All right, so then the last part is the velocity when s equals 0. So that means that we need to find the zeros of our position function. It's going to require us to throw it back to Algebra 2 and factor. And then we're going to have to see if all the solutions that they give work, because remember, we can't have negative time and we can't have negative position. So we can't have extraneous solutions, so we just need to, you don't have to check them like you did when you were back in Algebra 2 or even pre-cal. You don't have to be like, oh, I'm checking this solution. If it's negative, you can't have it. And then we're going to take that and we're going to plug that into the velocity equation. So my position equation, we're going to have 0 is equal to negative 16t squared plus 96t plus 112. So, factoring. Any recommendations on what we should do first?
Take out an 8.
Is that all I can take out?
I don't know if you can take out 16. Oh, you can. Wait. Yeah, you can take out 16.
Okay. So I would go ahead and also take out the negative just for convenience. I would switch and make these two signs negative and get rid of the negative here. So that becomes negative 16 times t squared minus, somebody's going to have to tell me what that is, and minus whatever that is.
60 minus 17. 7.
Is that right? What I have written there?
I said 7t without thinking.
I thought you said 17.
Not 7.
That?
Yeah.
Okay. Well, I was like, 17 and 6 when they're only a little bit off seems a little weird, but okay.
I said like 17 as a, like t is a variable, and then I realized it sounded like 70, and then I also realized it sounded like 17. I was like, there's like a whole lot of things you could have written, and all of them were wrong.
All right, so I can get rid of this 16 altogether. 16, there we go. So this is equal to t squared minus 6t minus 7.
Yep, and then you can factor into t squared minus 7. Wait, yeah, minus 7. Wait, no. Do plus 1 minus plus 1t
t times t plus 1 minus 7 t plus 1. All I've been doing in Algebra 1 is factoring for the last, like, 3 weeks, and I'm just like, I'm so done factoring.
Okay, so all of it is like a triple positive 1.
Somebody just fell.
Minus 7 triple positive 1.
What?
That's what my paper looks like, because there's like 3
Oh.
t's
Oh.
in a row. It's like t plus 1, so it's like a triple plus 1.
So this would imply then that t is equal to 7 or t is equal to negative 1. But we can't have that. Bad. Extraneous. Alright, so then I'm just going to do it over here. So then v of 7 is equal to, and we plug it into that derivative equation, so negative 32 times 7 plus 96 is equal to what?
$224.
I think that's just the first part.
I know, but I felt cool.
Oh. Since you felt cool, I'll write it down.
Yeah. Oh man, I got it right. Yeah. It's like 128. 128. It's a negative 128.
Feet per second. So that's the velocity when position is equal to 0. It's a little weird to think that the position is 0 and it's like negative velocity. That's weird.
Yeah.
But such is life. Okay.
And then we transpire this into physics. Combine physics concepts with this.
That was exactly a class that I took in college.
Yeah. See.
Physics that you could only solve using calculus, which was a false statement because it could be solved another way. They just decided that because I was a math major, I needed to solve them with calculus.
Yeah. See, that's like.
I was like, I'm not ever going to do anything with physics. Get hired here. You're teaching physics. Fantastic.
I was like looking at a lot of careers that like involve calculus, and a lot of them were like paired with physics because you would need calculus, so then you have to apply that to physics.
Well, that's what Garrett's been doing his college physics class, and so he'll like send me like questions sometimes that he like needs help with or whatever. And I'm not joking. Last night I worked like on a problem like simultaneously like while he was doing it for over an hour, and we still didn't get the right answer. And when he was like, I give up, like I'm just gonna get I'm just taking the L on this question. I was like, okay, like I'm with that because I genuinely don't know what to do, and it was due last night. And there were not numbers in the problem. Okay? There were no numbers in the problem. The answer was like 5.12 and 1.87. I'm like, how? Where did you get that from? I said, I've done a lot of physics. This might be the hardest problem I've ever done in physics. And I still don't understand why this is the answer. But I had the professor that he has, and I told him, I said, I honestly don't think she could have solved it. Like, I remember having her, and I don't think she could have. Because there was a lot of things we'd be like, hey, how do you solve this? And she was like, I don't know. I'm like, you have a degree in physics. Like, how?
Yeah, that would really hurt with my professor.
Well, and he has a test on it, and I'm like, I don't know how to help you, buddy. Like, I genuinely don't know because I have never seen a problem like that, and I don't know how they got the answer. I mean,
yeah, it's like
when we're done with it, I'll show you, like, all the work that I did to, like, try to get... Like, it was wild.
I like really don't want anything involved with physics, but a lot of the stuff, because I really enjoy calculus, but it's always paired with physics, and it's like, alright.
See, you might like this calculus, but you won't like Calc 2. Calc 2 make you want to cry. Yeah, I took Calc 2 twice.
Yeah.
Not because I had to, because I thought it might be a good idea.
You're wrong.
Oh, I was very wrong. All right. A piece of cardboard measures 10 inches by 15 inches. 2 equal squares are removed from the corners of a 10-inch side as shown in the figure. 2 equal rectangles are removed from the other corners so that the tabs can be folded to form a rectangular box with lid. I'm going to draw the picture, and we're going to go with that. So, we have, it's going to kind of look like a cross. So, we have, oh gosh. Okay, so it basically looks like this.
Wait, what?
just bear with me for a second. The dotted lines indicate where the fold is occurring. And then this is the base. This is the lid. We probably won't actually finish this problem. Well, we might. I don't know. It's not really that bad. It's just... Anyways. Okay.
Oh, I see. And then they fold it into a...
It folds into like a, a box with a lid. Okay. This is X. 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 Hold on. This is X. This is X. This is X. From here to here is 10 inches. And from here to here is 15 inches. Definitely not to scale. All right. We'll set up, we're not, oh wait, forgot the actual question's on the next page. That's how long this question is. We're only going to look at part A and D because that's really the only thing that's worthwhile. So part A says to write a formula V of X for the volume of the box. So the volume in general is length times width times height. Okay, I'm just going to set this up and then we'll continue it on Monday because I want you to actually be able to take your 15. So length is, we're going to call it this 10. We're taking out 2x, okay, because there's an x here and an x here. So 10 minus 2x. Hold on. I'm trying to see something because I've got...
X is simply the height.
But it's different because it's not actually 15 because it's part of the top. So the base would be half of the top, right? So it would be 7.5 minus x.
And then the
Because half of that,
Oh, that makes sense. Okay.
because we just need like this half of it. Because the lid and this piece should be equal to the base and this piece. So we're taking half of that and then times x.
Oh, okay, so
Because the height, it would be x.
the height, yes.
So then we'll just basically foil that out on Monday, but I'll leave that so we can re-talk about that. So that way it'll help us find the part D, because it actually wants us to find what the max volume would be for this problem.
So the lid plus that X part is half of the
Yeah, so from
got it.
here to here,
Is half of it.
yeah, it would be 7.5, and then from here to here should be 7.5.
Got it.